I'm going to do a short video on our next type or group of derivatives, which are trig derivatives. So we have 6 trig functions, and we have a derivative for all 6 of those trig functions. Now, the first 2 that you do already know, so number 1 and 2, I just want to make it a comprehensive list, but we have already talked about sine and cosine because those are considered our most basic derivatives. So the derivative of sine is cosine, and the derivative of cosine is negative sine. So next is the derivative of tangent. So I'm going to kind of just go across. I'm actually going to snake and do them this way and then this way. So tangent, our third one, derivative of tangent is secant squared. I'm actually going to do the one below it next because tangent and cotangent, we call those reciprocal functions, or sometimes they're called cofunctions. They have a similar derivative, but the cotangent is negative cosecant squared. And then I'm going to do these two kind of back to back because I think they're the most similar. So almost like partner them up. The derivative of secant is secant times tangent, and the derivative of cosecant is negative cosecant times cotangent. So you can think of sine and cosine as being similar, tangent and cotangent being similar, and secant and cosecant being similar. One of the most difficult things for students to remember is what's negative. And the best way to do that, if you look right now and say, okay, what's going to make them negative? All of your co-functions are negative. So your cosine derivative, your cotangent derivative, and your cosecant derivative. It's a great way to remember it. And what you'll notice is I'm only teaching you how to derive a basic trig function. The angle is always x or t, or we could use theta. And your function, nothing's being squared. That we'll get into those as we progress through the next few days, but right now we're just talking about the most basic type of derivative that we have with trig. So I have 5 examples at the bottom of the screen just to show you some variety of what you'll be asked to do. So first one is derivative of x minus tangent of x. You're just going to go term by term. So the derivative of x is 1, and the derivative of tangent is secant squared, so it's going to remain negative, 1 minus secant squared. Now, you may look at this and think, wow, that kind of looks familiar. I feel like that's an identity. Or you may not, because it's been a while since you've done trig identities. It actually is a version of our, we call it a Pythagorean identity. We have a Pythagorean identity that says 1 plus tangent squared equals secant squared. You learn a lot of identities in pre-calc trig. We don't use a ton of them in calculus, but we do tend to use the Pythagorean ones. So you may see like an AP test where you derive it, you get this answer, and then you look at the choices and it's not there. Well, what they could do is they could rewrite this trig identity. We could subtract the secant squared over here, subtract the tangent squared over here, and what we'll see is that 1 minus secant squared is equivalent to negative tangent squared. Next one, so you have an x times a secant of x. A flashing light bulb should be going off. You need to do a product rule on this. So I'm going to put a little PR next to it. Product rule, so first times the derivative of the second. Derivative of secant is secant tangent, plus the second times the derivative of the first. Derivative of x is just 1, so I'm not even going to write it. So there's my derivative of that. So now the next one, you actually have a couple options. So you could do a quotient rule with this, perfectly legal. I've had students look at the top and say that kind of looks like an identity. It looks really similar to 1, but it's not. 1 minus cosine squared is an identity. 1 minus cosine is not. One other thing you could do is you could actually pretzel this, and you could split it into 2 separate pieces. So what I mean by that is you could split it into 1 over sine. 1 over sine is cosecant. You should know your basic reciprocals. And cosine over sine is cotangent. So you could do that. You don't have to. You definitely could right off the bat just do a quotient rule, but I wanted to show you options. So the derivative of cosecant is negative cosecant cotangent. And the derivative of cotangent is negative, but it's already negative, so it's positive cosecant squared. Now, if you did this with a quotient rule, if you never even considered splitting it up, you would have a different looking answer. It would still be equal or equivalent. So you do, especially with trig, have a lot of ways to do some of these problems. So the next one, we don't really have a way around it. This one, you do have to do a quotient rule. There is no way to rewrite it without being division. I guess technically you could bring it to the top with a negative exponent and do a product rule. I don't like introducing negative exponents unless I have to. So I'm going to do a quotient rule. So bottom times the derivative of the top. The derivative of tangent is secant squared, minus top times the derivative of the bottom. So tangent x times just x, or derivative of x is 1, all over the bottom squared. And you're going to leave it like that. There's nothing I can do to simplify that. And then the last one, I did want to show you that the angle doesn't have to be written as x. It can be written as t's. It can be written as thetas. I personally prefer x, but I feel like sometimes with the trig especially, they'll use a different variable like theta. If you don't like it, you can change it. Delta Math does want you to use their variable's choice. So this is a product rule. So first times the derivative of the second. Derivative of sine is cosine. Plus second times the derivative of the first. I'm going to put the derivative of the first in the beginning just because I think it's easier to write that first. And then the sine of theta. One nice thing about the trig ones, even if you do have to use a more complicated rule like a product rule or quotient rule, rarely do you have to do a lot of extra simplifying. It's not like the algebra ones that take a few extra steps to be done with them. So those are your trig. You need to commit these to memory. You will be using them throughout the entire year.